Alright guys, welcome back to another week of our virtual learning. This will be week 5. This is pretty much going to be our last week of instruction like this. We're going to do things a little different this week where there's going to be this video and one more with some of the ed puzzle. And then we'll have a quiz midweek and study guide for a final at the end of this week. Alright, so and again, this is just stuff we've covered before when we were in the classroom. So don't be banging your heads on the walls thinking, oh crap, I haven't learned that before. It'll be okay. All right, right now we're doing graphing proportional relationships. The different ways of representing proportional relationships. Remember, there's a graph, an equation, and a table. Okay. So we do that, graphing proportional relationships. That's cool. We got it, the XY axis. We graph it. We take the data from a table. Those are our coordinates. Remember, we just pick them up and then drop them into the graph. We got to understand the connection between the proportional relationships, lines, and linear equations and all that. Remember, it's y equals mx plus b, our y-intercept, and our slope right there, okay? We're going to compare two different lines, two different proportional relationships. Remember we did that with the boathouse and the DJs back in the classroom when there was the initial value of $15 and then $5 per hour, and then the other one was no initial cost and it was $10 per hour after 4 hours. How long, which one cost more? That's all we're doing again. All right, let's take a look at this proportional relationship. I want us to, when we get this right away, take a look, xy, x comma y. It's coordinates, it's already set here. When we're doing our graph, we have x and y there, x and y, and then in our equation, x and y equals whatever is being multiplied by x from the y-intercept. So it's the same data, just different representations, okay? So, okay, let's take a look at this one. This one is showing two cars and the relationship in time, in seconds, and how far it goes in feet. So how fast it goes, remote control cars. Now, remember when we have a table, we got to find the difference in y and divide that difference in y by the difference in x. So remember, that's change in y divided by change in x. When we do that, let's see, 75 to 85 is 10. 85 to 105 is 20. All right, I'm kind of running out of room over here with this. 15 to 17 is 2. And 4. Well, 20 divided by 4. Let's take a look at this. 20 over 4 is, wow, is 5. 10 over 2 is 5. So, let me erase this. Car 1 goes how far? What is y? Feet. 5 feet per 1 second. So car 1 is 5 feet per second. Its slope, its rate of change, its proportion is 5 over 1. Now let's take a look at car 2. Oh, it's already written in an equation for us. And when we have the y equals mx plus b, this right here is our slope. This one goes 10 feet per second. Okay. Now I know this just, I'm going to touch on this real quick here. There is no y-intercept here. It would be 0 because it's starting, a race car starts still, it's not moving, so there's no place for it to start. So it's 0. All right, that's 0. So which one would be faster, car 2 or car 1? Yeah, car 2, it's twice as fast. So let's write car 1. An equation for that is y equals, what is my slope? 5x And then there's no, so let's take x and multiply it by 5 real quick. Just to double check. Plug and check. 25, 5, 6, 7. Yep. 5x. If we take this x and we plug in 15, we get 75. Okay? It all kind of works itself back. And remember, I keep telling you like it was a circle here. They kind of just circle back into each other. Let's take a look at this one. Okay, now we have two carnivals charging Y to go on X rides. All right, this is kind of like, well, which one do we want to go to? There's one over at Northfield, and there's one down at Southlands. A couple of carnivals. Which one do we want to spend less money on and go on more rides? It's pretty good. All right, let's take a look here. Well, this one's already got the equation for us right here. We have 2.5 x. So our rate of change, our slope, m, is 2.5 there. Well, let's say I want to go on 4 rides. I take 2.5, multiply that by 4, and I get, let's see, it's 10. Think of it as like quarters or dollars. $2.50 times 5 or 4, 10. Okay? Now let's take a look at this one. Cost for going to ride at Q. Let's take a look. Then I'm going to change the color. Okay, so we got 4 number of rides. This is our X. 4. So our X is 4. Our X is 4 there. Equals. Okay, so we have our Y over here and our X over there. Okay, let's see here. Let's write an equation. I'm going to erase all of this and let's just see what we can do to write an equation from what we know about this one pretty point right here, okay? Our Y is what? 5 equals, we need M, and our X is 4. All right, well, we can divide by 4 from both sides, and we get 5 over 4. 5 divided by 4 is 1.25. It's $1.25 per ride, whereas this one up here, it's 2.5. So this is half the cost. All right, see how it kind of comes in handy? We can spend $10 and go on 8 rides here. Well, that's pretty clear right here. So this is half the cost. The slope is double. So we can do twice as much with the same amount of money, okay? All right, let's take a look at this. Here is a graph, a proportional relationship between calories and grams of fish. So let's say you're a bodybuilder or you're on the soccer team and you're trying to get some protein for lean muscle and you want to know how many calories you get per gram of fish. So I know it's kind of hard to see here, but let's take a look here. Let's go to 100 grams of fish. Let's track this up. We hit a pretty point. Let's go this way. Mindful of what our units are here. These are not going by ones. Each line there is 50. So it's Y and X. Our Y is 150 and our X is 100. Okay. Let's track this up to another pretty point. Here's one right here. It's 200. X is 200. And my Y is 300. Okay. What's my change? Let me change the color here. My change in X is 100. And my change in Y is 150. So it's 150 divided by 100. Okay, 150, change in y divided by change in x. That gives us, it's 1.5 divided by 100. 1.5, just double checking that. So m equals 1.5. So for every gram of fish I get, I will get 1.5 calories. So 1 gram, 1 gram of fish gets me 1.5 calories. Okay? That does come in handy when you are calorie counting. I know there was a time where I was trying to get 2,500 calories per day, so that would help me like, okay, I got to separate that at how much fish can I have at dinner, all right? Okay, here's the same graph. I want you guys to write an equation that reflects this relationship using x to represent the amount of fish and y to represent the amount of calories, okay? The big chunk of it is done already for you, all right? And that's, remember, it's going to be in y equals mx plus b format, okay? Okay, same graph, same bit of data. Take what we got from your equation. Take what you got from the equation and see if we can fill in this graph. We kind of already did that on the previous slide there. Let's solve for A, B, and C. What would, let's see, let's make this, remember this. What's the x value going to be when there's 2001 for y? What is the y value going to be when there's 1,000 for x? Okay, plug those in. Let's see here. Go ahead and just write in the values. I don't need you guys to write the equation here. Just write the value for A, B, and C. What is A going to equal when we have 1,000 for x? What is B going to be when 2001 is the y? And what is C going to be when we have 1 for x? This one, if you paid attention in the previous slides, that one was answered for you, okay? All right, I know this will be pretty good for you guys. Remember, email me with any questions.